So guys, good evening everyone. Welcome to the session and welcome to the next class about the rank of matrix. And in this particular class, as I mentioned you that we are going to talk about a variety of questions. Yes. So because yesterday we have covered up the concept of rank of matrix, right? Yesterday we have covered up the concept of the rank of matrix, and today we are going to deal with several variety of questions. Not only the concept of rank. Yes, yesterday what is the concept of rank we saw, what are the different methods of solving it, determinant method, echelon method, dependency, independency, and ways to apply them, the approach to the questions, the shortcut to the questions. All that we discussed yesterday, isn't it guys? All that was discussed yesterday. Now let us move towards the variety of questions with respect to this topic. Okay, let us move ahead guys. This is anyways about me, you must be knowing. This is Rakesh, secured all India rank 9th in GATE and completed the masters from Indian Institute of Science Bangalore and been teaching for GATE EST for more than 12 years now. Right. Hi, good evening Tarun, Malti. Okay dear. So yes guys, the Sunday. Yes, the coming Sunday, that is 23rd April, for all GATE 2024 aspirants, I bring to you a free mega workshop. 6 prime factors to secure AIR under 100 in the GATE examination, and this is going to come up on the Byju's Exam Prep app, not on the YouTube. Okay, so you can register for this event on the Byju's Exam Prep app. I'll come live at 12:30 p.m. on the Sunday, okay, to talk about the very important strategy for GATE 2024. Now let us get started with the question guys directly. What would be the rank of this matrix? So we'll take up again different variety of questions, some basic questions, some good questions, okay, to be discussed in this particular session. So if you are able to see that, what is the rank of the matrix? What is the rank of the matrix? Now since it is an upper triangular matrix, okay, with this class you will also get to idea that which question quickly, which method to be applied, because yesterday we have talked about 3 methods. Number 1, fundamental determinant method, number 2 is the echelon form, and number 3 is the dependency and independency between the rows. Okay, now if you look into this particular matrix, it looks like an upper triangular matrix, right? This particular matrix is an upper triangular matrix, right guys? It's an upper triangular matrix. Okay, so what is going to be its determinant? For an upper triangular matrix, determinant is equal to product of the diagonal numbers. And this determinant, whatever may be the value, is non-zero, very clear. So there is a matrix whose determinant is non-zero, and there is a square matrix, very important. This is a 4 cross 4 square matrix. And very clearly we understood that whenever a square matrix has non-zero determinant, it will have the full rank. It will have full rank. For a 4 cross 4 matrix, full rank means 4. So rank of this given matrix is equal to the 4. Rank of this given matrix is equal to the 4. Correct answer is option number D. Correct answer is option number D. Correct? Yes, Doc. Okay, the correct answer is D. So whenever a square matrix, several times I specified this point yesterday, whenever a square matrix has non-zero determinant, its rank will be full, and for an n cross n matrix, a full rank means n. So here it is equal to the 4. Next question guys, moving ahead. Okay, now have a look into this matrix. Again, what is the rank of this matrix? I have put it into a numerical answer type question. So very clearly, once again, see, sometimes you can directly just start the determinant calculation. Okay, and what is going to be its determinant? Easy determinant, because one of the element is 0. Okay, so directly I come to the next element, which is -1, and its particular minor will be, okay, the second row and first column deleted, 0 -1, plus the third element of the row is equal to 1, right? And its minor will be 1 -0. Okay, -1 into -1, 1 plus 1, total determinant is non-zero. Total determinant is non-zero, right? Total determinant is non-zero. Again, there is a square matrix. Whenever a square matrix has non-zero determinant, it will have full rank. Non-zero determinant means full rank. So rank of this particular matrix, full here, means equal to 3, because it is a 3 cross 3 matrix. Because it is a 3 cross 3 matrix. So again, it will have the full rank, which is equal to 3. Okay, let's go to the next variety. Now let us add on something here. Okay, let us simply add on something here. Given the matrix 2 minus 3 4, 3 minus 2 5, 1 1 1, what is the rank of the matrix? What is going to be the rank of the matrix? Okay, number one, as we just solved. Method number one here. I'll now let us link the other methods also that we discussed yesterday, right? Yeah, linear system of equation will begin tomorrow. See, for linear system of equation, we need to have a clear understanding of rank. Okay, and that is what I first covered up, rank. Today we are solving the questions of rank. Tomorrow we are starting linear system of equation. Okay, tomorrow we are starting the linear system of equation. Okay, so what is the method number one? Dhyan dena. What is going to be the method number one? Let's see. The method number one, as the previous calculations, as the previous question, let me calculate its determinant. Okay, so it will be 2, then it's minor, minus 2, minus 5. Okay, then minus of minus 3, then it's minor, which is going to be 3 minus 5, and plus of 4, which is going to be 3 minus 2. Right. That is what it's determinant. Now let's quickly calculate what exactly is the value. This is minus 7 into 2 minus of 14. You get plus 3 but into minus 2, so minus 6. This is 3 minus 5. 5 4s are 20. So minus 20, minus 14, minus 6, minus 20. Cancelled with the 20. Answer is 0. Clear? So now think what is going to be the rank of this matrix. Okay, the determinant of the matrix is equal to what? The determinant of the matrix is equal to 0. The determinant of the matrix is equal to 0. Okay. So, what is going to be the rank? Definitely, the determinant is 0. So, the rank cannot be full here. Full means 3 because it's a 3 cross 3 matrix. So, definitely the rank cannot be 3. The rank cannot be full. So, what is the rank? So, guys, what I can do, I can test any 2 cross 2 minor. Okay, I can test any 2 cross 2 minor. Okay, calculate the value of this 2 cross 2 minor. Okay, let's calculate the value of this 2 cross 2 minor. 2 minus 3, 3 minus 2, and this turns out to be minus 4 minus plus 9, and this is non-zero. And because this is non-zero, 1 2 cross 2 minor is non-zero. At least 1 2 cross 2 minor is non-zero. Rank will be 2. At least 1 2 cross 2 minor is non-zero. Rank will be 2. Right? Okay. Now, one more thing that we can discuss here. Now, let us come to method number 2. Nothing new. I have explained you yesterday. Look into this method number 2. Okay. Now, guys, a simple operation, if you must have observed, observation that you have observed is, okay, subtract R2 minus R1. 3 minus 2 will be 1. Minus 2 minus of minus 3 will become plus 1. 5 minus 4 will be plus 1. 5 minus 4 will be plus 1. So very clearly I have a relation that whenever I subtract R2 minus R1, it is equal to R3. Okay, and that means I have a dependent row. Right. I have a dependent row. So out of the 3 rows, very clearly, one of the row is dependent. Okay, so how many independent rows? It is equal to 2. And then what we learned yesterday is rank is equal to number of linearly independent rows of the matrix. Okay, so we can directly say that the rank of the matrix is equal to 2. So whenever you feel that there is one dependency, so of course we have 2 independency, and the rank is equal to 2. Clear? Done. Okay. Chalo. Even if you want, we can apply the echelon method here, but not required. We'll use echelon method also. Okay. So sometimes, okay, determinant method se to aapne solve kiya hai, but sometimes what can be quick is this method. Okay, checking the dependency, and if you are able to feel that there is dependency, you are able to simplify your answers. Okay, let's move to the next calculation. Let's now move to the next calculation. Yes. What is the rank of the matrix? Anyways, dear, this given matrix is 3 cross 4. It has 3 rows and 4 columns. So anyways, it's a non-square matrix, so you cannot calculate its determinant. You cannot calculate its determinant. That is very sure. Because determinants are applicable only for square matrix. Okay. So there is no point of calculating determinant here. Now how to determine the rank? Okay, you can go for calculation of minors or calculation by the echelon form or dependencies. Okay, I'll show you that. Don't always restrict yourself to the dependency of rows. Sometimes it can be dependency of column as well. Sometimes it can be the dependency of columns as well, right? So can we check here the dependency of columns? Can we check here the dependency of columns sometimes? Okay, have a look into this. I'll show you how. 2 into 2, 4, 3 into 2, 6, 1 into 2 is 2. Very clear, right? So this is into 2. Okay, which into 2? Column 2, when you multiply by 2, you get column number 1. Column number 1 is twice of column number 2. Very clear. Column number 1 is twice of column number 2. This is one column dependency. Anything else? Chalo, let me remove this now. Yes. There is one column dependency. Now, very simple calculation. 2 plus 1 is 3. 3 plus 4 is 7. 1 plus 0 is equal to 1. 1 plus 0 is equal to 1. 2 plus 1 is 3. 3 plus 4 is 7. 1 plus 0 is equal to 1. 1 plus 0 is equal to the 1. Correct? Okay. That means whenever I add column 2 and column 3, I am directly getting the column number 4. So next is column number 4, which is equal to column number 2 plus column number 3. Which is equal to column number 2 plus column number 3. Column number 2 plus column number 3, right? So that is what? C4 is equal to C2 plus C3 and C1 is equal to 2C2. Okay, so I have two dependent columns. Okay, I have two dependent columns. Very clear that I have two dependent columns. Okay. Now, how many columns I have? Two dependent columns out of what? Out of 4. So, how many independent columns I have? How many independent columns I have? Out of the 4, 2 dependency I have shown you. So, there are 2 remaining independent columns. Method is applicable on rows or columns, any of them. So, I have 2 independent columns. Okay, I have 2 independent columns, and that is why I can say that the rank of the matrix, as I told you, is equal to number of linearly independent rows or number of linearly independent columns. Okay, number of linearly independent columns. So here it is what? Number of linearly independent columns. Anything you can apply, right? Yes, Tarun, please tell me. So rank is number of linearly independent columns here. Correct? So answer is equal to 2. The rank of this matrix is equal to 2. The rank of this matrix is 2. Very correct. Let's move ahead to the next variety. So that's what I'm telling you. Sometimes this dependency and independency method can be very helpful in saving your time. If you're able to observe that there is dependency, we save a lot of time. Let's go to the next case. Let us go to the next case. Okay. Now, this question is again going to be, right? This going to be very simple. Only thing is it is good in the language. Matlab matrix is not directly given. You have to form the matrix. Good evening, Arjun. Right? Increasing zeros, Pratiti. Right? ROZ is not compulsory. That's what I told you yesterday. Na? ROZ, if any, it must be at the last. Okay, if it is not there, no problem. But at least increasing zeros must be there. Strictly increasing, not even same. Okay. Now the only good thing is the question finding out the matrix. Okay, that is also not very big task, but still, okay, that is decent. Otherwise, rank calculation to easy hoga. So let A is equal to Aij, right? Where I and j belong 1 to n, when I and j are in the range of 1 to n is greater than equal to 3, and Aij, any particular element is I into j. Any particular element is given by the product of I and j. That is given by what? Product of I into j. So let us first form this matrix. Okay, n is any value greater than equal to 3. Let us take n equal to 3. It will not going to harm. Okay, so let us take for simplicity n is equal to 3. Right? And if n is equal to 3, my matrix is going to be how much? As I told you, matrix is is given by the elements which is aij, and the n is equal to 3 I have taken. N is equal to 3 matlab 3 cross 3 matrix, so this should be a11, a12, a13, a21, a22, a23. Okay, then a31, third row first column, a32, a33. Right, this is a 3 cross 3 matrix. I have taken n equal to 3. I have taken n equal to 3. Right. So aij is what? Everybody must know. Aij is the element lying in the ith row and jth column. Okay, that is aij. Now, this is further equal to how much? This is further equal to a11. Now, aij is I into j. So, a11 is 1 into 1, which is 1. a12 is 1 into 2, which will be 2. a13 will be 1 into 3. a21 will be 2 into 1. a22 means 4. a23 means 6. a31 means 3, 3 into 1. a32 means 3 to the 6. And a33 means 3 into 3, which is equal to 9. Which is equal to 9. Correct? 1, 2, 3, 2, 4, 6, 3, 6, 9. Now guys, you should be able to say, yes, Sagnika. Yes, Sagnika. Correct answer. Okay. Yes, Dark. I will plan that separately for EC students only. Yes, definitely. Because since it is ISC Bangalore, so I think there can be a question also for EC next year based on the analysis of previous years, I feel. Chalo. Tell me, dear. What is the rank? Chalo, Arjun says 1, Sagnika says 1, Abhishek says 1, right guys? So dekho, what is the point here is, okay, 1 2s are 2, 2 2s are 4, 3 2s are 6. So very clearly the second row is twice of first row. Then 1 into 3 is 3, 2 into 3 is 6, 3 into 3 is 9, right? So when you multiply row 1 by 3, you get the row 3. You get the row 3. Okay, now recall what I taught you yesterday. One important, very important point I told you yesterday. One very important point I told you yesterday, that all rows are proportional. All rows of the matrix are proportional. R1, 2R2, 3R2. Okay. All are proportional, dependent on each other. Right. Okay. So, whenever all rows are proportional or identical, whether they are proportional or identical, rank of such a matrix is equal to 1. Rank of such a matrix is always 1. Acha, we can say other ways also. What is the other way of saying it? Other way of saying it is, aap isko aisa dekh lo. I will put down one more remark here, that I have two dependent rows. R2 is 2R1, R3 is 3R1. So both R2 and R3, it is dependent on R1. Both the R2 and R3 is dependent on R1. So I have two dependent rows. So I have only one independent row. So I have, because two are dependent, so I have only one independent row, right? And that is why rank is also equal to 1. Rank is equal to number of independent, linearly independent rows. Done it? Done है? चलो let's move to the next. Let A be a matrix 2kk, kk2, k2k, and if the rank of the matrix is 1, now very clearly, rank of the matrix is 1, then what should be the value of k? Reverse thinking you have to apply here. Okay, maybe reverse thinking you'll have to apply here. Okay, the rank of the matrix is 1, so that all rows are proportional or identical. All rows are proportional or identical. या तो proportional होने चाहिए या identical होने चाहिए. Right? Okay. So rank of the matrix is 1. That means all rows are either proportional or identical. Now here it cannot be proportional. Why? Because this is k and k. Okay, if it is proportional, this has to be like 2k or 5k or 6k. Then we will relate with 2 and calculate k. Similarly, this is k and k. Right, so here only identical can work. Proportional cannot work. Here only identical can work and proportional will not work. Okay, proportional will not work. Proportional will not work. Okay, proportional will not work. So identical. Now identical होने के लिए ठीक है, these two are same. So this also has to be same. All are identical. So k should be 2. Right. So what is the answer? K is equal to 2. For the rank equal to 1, all rows are identical here, not proportional, and that is why the k should be equal to 2. That is why the k should be equal to 2. And of course, if k is 2, look into this matrix. If k is equal to 2, all elements are 2, matlab all rows are equal. First row, third row, and second row, all the rows are just equal to each other. All the rows are just equal to each other. It is going to look something like this. It is going to look something like this. यहाँ पे अलग से लिख देता हूँ. All rows are identical. Okay, such a matrix has rank 1. Such a matrix has rank 1. Clear? Okay. So please take a note of this. Let's go to the next question. All right. Again, a 3 cross 4 matrix, non-square matrix coming into picture. 3 cross 4, a non-square matrix coming into picture. Now, if I, sometimes, of course, it is our tendency to try dependency and independency because that is helping us in solving the question simply. Okay. So 1 into 2 is 2, minus 2 into 2. No, this is not matching, right? 1 minus 1 is 2. But minus 2 minus 4 minus 6 यहाँ पे नहीं है. So that subtraction is also not working because if you find a dependency, it has to be applicable on all the elements. It has to be applicable on all the elements. I don't say they are not dependent, but sometimes dependencies will be so indirect and so hidden that finding it will eventually waste your time. Finding it may eventually waste your time. Okay, like I think this is 1 into minus 2, but that 2 into minus 2 is not satisfied here, right? Maybe minus 2 into minus 2, right? Okay, that will become 4, but यहाँ पे 4 into minus 2, that cannot be 0. Okay, so somehow directly maybe sometimes we are not able to judge the dependency. It may be dependent. I'm not telling that they are not dependent. It may be dependent. Okay, because guys, what? R2 is equal to 1.5 R1 minus 7, plus 7.25 R3. This is also a dependency, na? Who told it is always have integral numbers? So 1.5 R1 plus 7.25 R3, that is also known as dependency. So it may be the case that there is some sort of dependency whose numbers you are not able to figure out directly. You may take time. And if you are taking time, then this method is of no use. Na? The dependency method is to save our time, not to waste our time. So whenever you feel that, okay, sir, directly dependency, I cannot judge. Maybe I'm not able to judge. So what will I do? I will straightforward go to the echelon method in that case. Because it is a non-square matrix, determinant method bhi nahi lagayenge. Straightforward, I will go to the echelon method. Okay. So let's start with the echelon method here. Let me rewrite the matrix for that. 1 and minus 2 and 0 and 4. Okay. Then I have 2 minus 1, 1 minus 2. 2 minus 1, 1 minus 2. Right, and then minus 1, 4, 2, 0. Minus 1, 4, 2, 0. Clear? Acha. Now, let m be the number of starting zeros like yesterday. Like the yesterday, same notation. Let m be the number of starting zeros. Let m be the number of starting zeros. What is m here? There is no starting zero here. There is no starting zero here. There is no starting zero. कहीं पे भी starting zero नहीं है, so that means m is equal to 0, 0, 0. They are all same. Okay, this is just a same trend. Okay, so the given matrix is not in the echelon form. The given matrix is not in the echelon form. The given matrix is not in the echelon form. Very clear, everybody. The given matrix is not in echelon form. So let us convert this into echelon form. And to convert it into echelon form, what I need to increase the starting zeros. Initially, it may be 0. Next, it may be at least 1. Then uske baad more than 1. It must be strictly increasing. So my first target will be to convert at least the 1 element, at least the first element to 0. let us start adding the starting zeros, and starting zeros means let us add first element 0, and for that isko 0 karna hai to 2 minus 2 into 1. Okay, operation has to be applied to entire row, not only to a single element, na? So I will write down here R2 is equal to R2 minus 2R1, right? And isko 0 karna hai to minus 1 plus 1, directly add. So I will write down R3 is equal to R3 plus R1. R3 is equal to R3 plus R1, right? So doing this much, what is going to be my matrix A if I do this much? First row is same, 1 minus 2, 0 and 4. Then I have, okay, 2 minus 2 into 1, 0. Minus 1 minus 2 into minus 2, this is 3. Okay, 1 minus 2 into 0, 1. Minus 2 minus 8, that is minus 10. Minus 2 minus 2 into 4, that is known as minus 10. Right? Then R3 plus R1, too, that is minus 1 plus 1, 0. 4 minus 2 is 2. 2 plus 0 is 2. 0 plus 4 is 4. 0 plus 4 is 4. Okay. Okay. Nahi, dekho, if you get two rows which are totally equal, then there, you can stop in between universal, and you can also include the dependency and independency case. Na? You can save time if you want there. Right? Chalo guys, now what is the starting 0 range? 0. Here I got one starting 0, but again next row also has one starting 0. This cannot be the same. Starting zeros must not be same. If they are same, then the matrix is not in echelon form. So I have to increase the starting 0. So isko bhi increase karna padega. So you have one starting 0, here it should be more than one, at least 2 or 3 starting zeros. At least the 2 or 3 starting zeros. So to convert this into 0, what I am going to do? To convert this into 0, now I will write down R3 is equal to R3. Okay, I will multiply this by 2 by 3. 2 by 3, 3 will cancel, 2 will also cancel. Okay, so minus 2 by 3 R2. Minus 2 by 3 R2. ऐसा करने पे जो matrix A होगा, look into this. First row remains to be same. 1 minus 2, 0 and 4. Second row I am also not disturbing, that is already done. 0, 3, 1 minus 10. Then R3 minus 2 by 3rd R2, 0 minus 0. Okay, sir. 2 minus 2 by 3rd, this is 0. Okay, 2 minus 2 by 3 of 1. So 2 minus 2 by 3, 4 by 3. Okay, and then 4 minus 2 by 3. Minus of course plus ho jayega. So 2 by 3, 20 by 3. Okay, so I'm getting the number which is like 4 plus 20 by 3, so 32 by 3. 32 by 3. This is 32 by 3. Everybody clear? This is 32 by 3. This is 32 by 3. Now what is the trend? Number of starting 0. First row, nil. Second row, how many starting 0? 1 starting 0. Third row, how many starting zeros? Clearly 2 starting 0. Do they follow increasing trend? Do they follow the increasing trend? Do they follow the increasing trend? Do they follow the increasing trend? Yes. Strictly increasing. And I want strictly increasing. Same nahi hona chahiye na? Yes. They follow strictly increasing. So given matrix is in row echelon form. Okay. Given matrix is in row echelon form. So I have obtained row echelon form now. I have now obtained row echelon form, and hence what is going to be the rank of the matrix is equal to number of, what I told you, rank of the matrix is equal to number of non-zero rows. Number of non-zero rows. Number of non-zero rows. So first non-zero row, second also non-zero. Zero row means completely filled with 0, right? Third non-zero row, all are non-zero. Okay, so how many non-zero rows? 3 non-zero rows, so rank is equal to 3. And that is why, rank is 3. That means all the 3 rows are independent. All the 3 rows are independent, and that is why maybe you were not able to find out the dependency. Clear? Right, everybody? Yes, it is beneficial for all branches because linear algebra is an important chapter for all topics. Rank, linear system of equation, it is important for all. Right? It's done on the n side. I mean, okay, they might be trying to do it column wise. You can do anything, either row transformations or column transformations, dark current. Don't worry. can do both. Okay, guys. So let's move to the next question then. Let us move to the next question. Okay. If a matrix has rank, if a matrix has a rank n, row is also, row is also the representation of rank. Row means rank only, and that is equal to n. What can be the rank of adjoint A? What can be the rank of adjoint A? Think. What can be the rank of adjoint of the matrix? So dear, what is the formula for adjoint? Actually, adjoint can be related by the inverse wala formula. We know that A inverse is adjoint of A divided by modulus of A. Acha. So what is the adjoint of A? What is the adjoint of A? Mod A into A inverse. Mod A into A inverse. Clear? Mod A into A inverse. And guys, the determinant of adjoint A. Okay, you must be knowing this as a property. अगर नहीं पता है तो note कर लीजिए. The determinant of adjoint A is mod A power n minus 1. Okay, sometimes if I take classes on matrix, fundamental matrix and determinant, I will cover this point, but this is very basics. If you don't know, you can note down right now. Modulus of adjoint A is mod A power n minus 1. It is known as mod A power n minus 1. Clear, everybody? It is known as mod A power n minus 1. Now, for a square matrix, okay, rank is n. For a square matrix, n cross n square matrix, the rank is n. That means the rank is given to you as full. What is given to you? The matrix has full rank. And the matrix has full rank. That clearly means that its determinant is non-zero. Because so many times now we have covered this point that if determinant is non-zero, then the matrix has full rank. Here full rank is given to you. That means the matrix has non-zero determinant. Okay. And because the matrix has non-zero determinant, what about the modulus of adjoint A? That is also non-zero. That is also non-zero because it is mod A power n minus 1. Okay, if it is a non-zero number, its power also will be non-zero only, no? Right? So that means I can say that adjoint A is a matrix whose determinant is non-zero, and for any square matrix whose determinant is non-zero, it will have full rank. Okay, it will have full rank. So here I can say that adjoint of A has full rank, that is n. The adjoint of A will also have full rank, that is equal to n, and the correct answer will be option number A. The correct answer will be option number A. You can go by verifying the options as well, but this is a very simple logic. In fact, I can even generalize this point. In fact, I can generalize this point for you that what is the rank of adjoint A? Rank of adjoint A. The first condition you saw that it is equal to n. It is equal to n if rank of A is also given to be n. If all rank of A is also given to you as n. It will always be equal to 1 if the rank of A is n minus 1. If the determinant of the matrix A will be 0. The next condition that if the rank of A is less than n minus 1. Now, see, adjoint banta kaise? Very simple logic. How do you form the adjoint? Adjoint is formed by taking the cofactors of matrix. Cofactors depend on minors. What is cofactor? Minus 1 power I plus j. Cofactor Cij is known as minus 1 power I plus j into Mij, where Mij is the minor. Right? I am telling you that rank of the matrix is less than n minus 1. That means all the minors of order n minus 1 should be 0. Because, listen to me, just one line. Because if any of the minor of rank n minus 1 was non-zero, then rank will be n minus 1. Na? Then rank will be n minus 1. So rank is less than n minus 1. All minors of the order n minus 1 are 0. So all the cofactors are 0. And if all cofactors are 0, adjoint mein bacha kya? Adjoint matrix is obtained by cofactors only. So if all cofactors are 0, all elements of adjoint A are 0, the adjoint A itself is a null matrix. And what is the rank of null matrix? Yesterday we studied. What is the rank of null matrix? 0. What is the rank of null matrix? That is 0. That is 0. The simple logic is because adjoint of A will be null matrix. Will be null matrix whenever rank of A less than n minus 1. Less than n minus 1. Right? Less than n minus 1. Right? All cofactors of size n minus 1 are 0 because rank is less than n minus 1. Na? Okay. That is what is the general conclusion about rank of adjoint A. You can note down any of the case can be asked you in the question. What is the rank of adjoint A if the rank of A is n or n minus 1 or less than n minus 1? They can ask with the given value of n as well. They can give some value of n, maybe 3 or 4, anything. Right. So important point, please note down. Okay, the rank of adjoint A. Important point, please note down. That is known as the rank of adjoint A. ठीक है जी. Chalo guys. Okay. So this is all generalization. That's it. Now see you tomorrow. Okay. What is the topic coming up tomorrow? What is the topic coming up tomorrow? First of all, we start with non-homogeneous linear system of equations. Non-homogeneous linear system of equations. Non-homogeneous linear system of equation. So tomorrow we'll start homogeneous system of equation. Sorry, non-homogeneous, then homogeneous. Next class homogeneous. Okay. Yes, definitely. I'll share you the link. I'll share you the PDF in my Telegram group. What is the password for the PDF? Chalo, let me keep a very simple password randomly. That is linear. Okay, guys. What is the password for the class? For the PDF of today's class? That is linear. It will be in my Telegram group. Yesterday's class PDF is also shared in my Telegram group. Today's also will be shared, and password is going to be linear. LINEAR. Everything in small. That is the password. All those who have watched right now, yeah, maybe later you have the password. You can access the PDF. Otherwise, the PDF will be password protected. Okay, guys. Thank you. Thank you, Nishu. Okay, guys. That's it from my side. See you tomorrow with non-homogeneous linear system of equation. Bye-bye. Good night. Stay safe and take care of yourself.